Hello and welcome to another video of this series about object-oriented programming. In this video I'll introduce the concept of chaining constructors, the purpose of which will be to ultimately remove the redundant code that we've come across in a previous version during app 1.4. So the new version will be 1.5. What is the current status in the latest version? This is a rectangle class displaying the 4 constructors as implemented in the hands-on video. So we have a explicitly defined default constructor. We implemented a copy constructor, a constructor with 2 parameters, and a 4 parameters constructor. Each constructor calls the necessary setters. And everything worked just fine. Still, there is a problem with this implementation. It is namely not very efficient. Actually, you have several problems. What we note here is that first, a lot of setters are invoked. Each constructor calls its necessary setters. So the default constructor calls the set height and width with a specific value. The copy constructor invokes the 4 setters. The 2 parameter constructor just 2 setters, because as with the default constructor for x and y, if you don't call a setter, then the default values will be set to 0, which is just fine. And then the 4 parameters constructor invokes the 4 setters. But the problem is that in none of the constructors may we forget to call a setter, and it's just too easy to do that. For example, in a copy constructor, if we don't invoke the set height and set width, we don't get a compiler error. So we are not enforced to call the setters, but at runtime that will result in an object being in an invalid state. Namely, the rectangle will have a height and a width of 0, which is not acceptable. And suppose that in the later stage a new property will be added to the rectangle class, say color. A property that will be very handy if we want to use a rectangle class in a desktop application or in a mobile app where we want to draw the rectangle in a specific color. So we add a property, implement the necessary getters and setters, but then whenever a rectangle is created, we will have to invoke the set color in each of these constructors. And it's all too easy to forget one call. So the current implementation is quite error-prone. What is a better way to prevent properties from being uninitialized? Chaining constructors. How does it work? Here the chaining is already implemented. So what's the idea? Well, first of all, have only the constructor with most parameters invoke all the necessary setters. So what is a constructor with most parameters? It is this one. The constructor with 4 parameters. X, Y, height and width. Only this one will invoke the necessary setters. The second step is then to have the other constructors invoke that constructor by passing the necessary arguments using the this invocation. What do I mean by that? Let me explain it first of all with the default constructor. So what we do is, as we'll see later, we won't be able to, for now, use any constants, so I'll need to comment this. I replace the invocation of the 2 setters, set height and set width, by this notation. So it is this and then 4 arguments. The this invocation is actually an invocation of another constructor in the same class that is able to receive 4 arguments, and it is this one. Okay. The this invocation is like calling the other constructor, passing along the way 0 and 0 for x and y, and then 10 and 10 for height and width. In turn, this constructor will then be executed, calling its setters, after which we return to the default constructor. It was the only statement in this case, and then control will be resumed in the client. And that's how it works with the other constructors. Let's have a look with the copy constructor. Again, this invocation, and here we pass all the necessary properties of the other rectangle, to which we have a reference via the parameter rect. So we pass rect.x, rect.y, rect.height and rect.width to that same constructor. And then the last one, the 2 parameters constructor invokes the same constructor passing 0 and 0 for x and y and parameters, height and width to 4 parameters constructor. The advantage of which is that it becomes less error prone. Because first, the constructors using this invocation must pass 4 arguments. Passing not enough or too many arguments will result in a compiler error. None will be forgotten, and thus all the necessary setters, 4 in our case, will always be invoked, no matter which constructor the client decides to use when creating an object. And second, let's examine the situation when we add a new property, color property. What we can do then is add a new constructor with 5 parameters, and the 5th parameter will then be a value of a color, for which we invoke the setter. And the other constructors, if they want to use that constructor, so first of all, the code will not break because we will overload this constructor, so we keep this one with 4, but we add a new one with 5 parameters. If we want to use that one, then we can add a new argument to the argument list for the invocation. A few remarks. The this used in the this invocation is not the this pointer. We have seen this before. That was in the videos about encapsulation and validation. Have a look at the code that you use in the setters. And there the this represents the this pointer, a reference to the current object, which I explained very explicitly in the under the hood videos. But the this here is not the this pointer. It is just saying, okay, I want to invoke another constructor from the same class. It's similar to a method invocation, whereas in this case we don't invoke a method but another constructor. Now, I find this notation a bit confusing. I think it would have been better to use the name of the class or so. So in Java, if you want to invoke this 4-parameter constructor, you use this, which refers actually to the other constructor, and then you pass 4 arguments along the way. I prefer the notation which is used in C++. There, if you want to have the same behavior, they use the name of the class. So this, to me, looks more like, okay, I'm invoking this method called rectangle, and I pass these 4 arguments. I find this notation much clear. I don't know why they've decided to use this. I find it a bit confusing. Again, this doesn't represent the this pointer. No, it just refers to the name of the constructor of the same class. Okay, so that for the current implementation. Now, there is a problem actually. Namely that the this invocation must be the first statement in the constructor. We may not execute anything before the this invocation, not even define any, for example, final variable. See previous slide and hands-on. I'll demonstrate that in the hands-on video. But see previous slide, allow me to go back for a sec. What do I mean by that? Well, maybe you notice that in the default constructor, in the previous version, I defined a few constants, a few final variables, and I use those values in order to pass them to the setters, set height and set width. I'm not going to use setters anymore, but I would still like to use these constants. Well, I can't do this. Why? I'll explain that in the hands-on video. Now the client's version 1.5 is exactly the same as the previous version. Its code will compile just fine and the output will be exactly the same. Just behind the scenes, the implementation is a bit more structured and less error prone. Let's implement all this in the next video, the hands-on session for version 1.5. And what I'm going to demonstrate is first of all add in the lib package demo05 chaining constructors and implement the discussed topics in the rectangle class. And in the app package, add package demo05 chaining constructors as well, and use the new topics of the rectangle class in the new version of the drawing app. If you like this video, then thank you for pushing the like button or subscribing to my channel, and see you in the hands-on video. Bye bye.